Hello everyone, this is Clifford Kian from Peaznchips Productions. Welcome back to my Unreal Engine game creation breakdown series, where we will be breaking down the making of a game from initial concept to final product, using my recently created game, USEU Arena, as an example. In this series, we are currently building a VR shooter prototype, and a previous video covered creating a project from the Unreal Engine VR template and modifying the motion controller pawn class to handle basic forward, back, and strafe movement based on the direction that you're looking. So please check out that video if you haven't seen it yet. In today's video, we'll carry on with the prototype and add snap turning, which is turning by increments, and the creation of a bullet that we can shoot. So let's get started. We'll be starting from the motion controller pawn, and we'll be adding a new function called snap turn right. So this was the motion controller pawn that we had ended up in the previous video, where we added our linear velocities. Now in this case, there is a node called add controller your input. Now your rotation is the rotation around the z-axis, which is, if you had to imagine you spinning from the top of your head around from the top to the bottom, it'll be that axis. And snap turn is a very distinctive turn, so it's not a continuous rotation. So in this case, we're going to be creating a variable to hold the amount of angle that we want to turn, and apply that to your input node. So in this case, it's 25 degrees, and it's a positive number, so it's in a clockwise direction. And we're going to now create another function called snap turn left, which will be exactly the same, except it will be rotating in an anti-clockwise direction. So we're going to take the same snap turn angle, and we are then going to multiply that by -1, so it'll be in the anti-clockwise direction. But before this will actually work, we actually have to tell the pawn that it is actually able to accept values for your rotation. So there is a checkbox there which you have to then tick to say use controller rotation your. So once we've done that, we then actually have to hook it up to our right thumb controller events. Now the values that we get from the motion controller thumbsticks are not just distinct values, or not discrete values rather. They are remember, they are a continuous value from 1 to -1 direction, depending on which direction you are facing, turning the thumbstick. So we need to make these into very discrete pushes to the left or to the right, so that it becomes a more a binary type of motion. So much like pressing a button once and then incrementing a turn by a certain angle, we're going to do the same thing with the thumbstick. Once it has been pushed past a certain value, in this case 0.7, it will then register that turn. And similarly, if we get a value to the left, which would be less than minus 0.7, then we'll register a snap turn to the left. So the values there are greater than 0.7 and less than minus 0.7, which means that any value sitting in between there essentially won't be registered. It will act like the dead zone, but it is also going to act as our reset zone. So once you've gone past 0.7, what we don't want it is to keep calling the snap turns to the right, because you'll get a continuous rotation. But what we want to do instead is allow the thumbstick to be pushed to the right and then do one snap turn, and then you'll have to return back to the center and then to the right again before you can do another snap turn. So that would be the equivalent of pressing a button and releasing a button and then pressing the button again. Now we're going to just create a Boolean variable to keep track of whether we've done a motion to the right or to the left already, and then only reset that value once you have gone back into the dead zone. I'm just going to call this value snap reset. So the default value for the snap reset will be true, as in it has been reset to the middle, and then once you have pushed it past to either to the right or to the left, then we will then set that to false. And then we just have to add that snap reset value as to being part of the condition. So before you can do another turn to the right, you will have to go beyond, you have to push right beyond a certain point and have been back to the reset zone. So that's what that condition there does. And we'll have to do something very, very similar to the left direction on the thumbstick. Right, so I'm just going to update that where we actually reset the value to being true. That logic wasn't quite correct. So I'm going to distinctly check that the controller has moved below positive 0.7 and above negative 0.7, i.e. back into the dead zone. I'm going to check that for that explicitly before I reset that snap reset Boolean value. And there we have it hooked up. Just going to do a little bit of cleanup of the connectors. Just like in normal coding, what we call spaghetti code, you can actually do in blueprints as well, so we'd rather not have it. But here we have it running, and here I'm pushing right and left on my controllers, and you can see a very distinctive left and right turn. So that angle was a little bit too large. I'm going to just decrease it there from 25 to 10. Because it becomes a little disorienting when if your snap turns are too big, you're not sure which way you're directing from where you were. And now we're going to go on to the creation of a bullet. So we're going to start off by just creating our own folders, because this is going to be a completely new blueprint that we are going to be creating, and not a blueprint that we're modifying. So here we're going to create a new blueprint, and we're going to make it of a type actor. An actor is a class that can be placed within the level, and we will want to be able to place a bullet into a level. So I'm just going to call it BP underscore bullet, and then I'm going to start modifying this. I'm going to add a box collision to the blueprint, because it's going to be a physics type object. We want us to be able to move according to some sort of physics, or give it a velocity, and interact with environment. And then I'm also going to provide a static mesh. So this will be more the visual aspect of the bullet itself. In this case, we're just going to, because we're doing a prototype, I'm just going to use a very, very simple existing box that comes with Unreal Engine, and just scale it down into a reasonable size. And the same thing for the actual collision box, to make it a similar size to what it is visually. Now, just like the motion of our pawn, we have to switch on physics onto the collision box. So I'm going to click the simulate physics box. We don't want it to be affected by gravity. And we also then want to set what type of collisions that it can interact with. So you have to tell it that it's a physics. In this case, it's only going to be physics. And the actual object type itself is world dynamic at the moment, and it can interact with world static and world dynamic objects. So world static are normally things that are like walls and floors. World dynamic tends to be physics objects that are moving around. So if I look at my class settings, I don't have any interfaces for this. So one of the things I like to do is create interfaces for every object or each blueprint that I create. It makes programming a little bit easier with blueprints, because very often when you're dealing with different actors, you have to cast them from an actor type to to whatever class you're working with. In this case, for example, a bullet before you can use its functions. But when you have an interface, it makes it a little bit easier in that you don't actually have to cast your objects into the types before you can call their functions. As long as you know that it implements that particular interface, you can just call the interface directly. It just makes for a little bit of cleaner code. In this case, I'm adding a function called setVelocity because we want to be able to set the velocity of the bullet once it has been added into the level or dynamically added into the level. So here we just tell it to implement the interface called bullet. And we need to compile it, and there that interface becomes available to us. And now we're going to actually implement the functionality of that interface, just as you would in normal programming. So the box is which we had made a physics object previously. So here we can actually set a velocity, set physics linear velocity on it. So we're just going to pass the velocity in as a parameter. This is almost identical in the way that we did the motion of the pawn. And because we're creating a bullet, we'll be shooting off a lot of these bullets, and what I want to make sure is that they don't last forever. So if you shot a bullet off into the sky, it would just keep traveling. And if you shot off 100 bullets, then 100 bullets would exist at any time, and they would just keep traveling even if you couldn't see it. So we're going to make sure that these bullets only last for a certain amount of time, and then they will destroy themselves. So that's what the destroy actor node does over there. And in the event begin play, so it's as the actor is created, it is then going to set a timer that's going to call the destroy function after a certain amount of time. I think in this case I'll probably make it 5 seconds. So after 5 seconds, the actor will then destroy itself and remove itself from the scene. So now that we have an actual bullet, we need to be able to create that bullet when we press the trigger button. So the first thing I'm going to do is just create a function called fire right, actually. So fire right will be the right hand motion controller's trigger. So I'm going to then connect that up. The two things that we'll want from a motion controller is the position it is in space and the direction that it is facing. So this is so that we can create the bullet at the correct spot, which will be where our hand is, or if you had a gun at this point, it would be where your gun is, and then you'll also want to shoot it off in the direction that your gun is facing. So we're just going to get hold of the motion controller, and we're going to get its forward vector. So this is the forward direction in which the motion controller is facing. and then we want to get the world location of that motion controller. Once we have those two values, then we will be able to create the bullet at that point. So there is a spawn actor from a class node in Unreal. So we're going to place that down, and we're going to tell it that it must create a BP_bullet type actor. So that's what we do by specifying that class. You can, when you create the actor, you can set its initial transform. A transform consists of its location, its rotation, and its scale. We are only really interested in its location. So you can make that transform from its consecutive parts. So we're going to hook up the location just to the location portion of the transform. Not interested in its rotation, and the scale of 1 is just perfectly fine. Normally when you create an actor, it needs an owner. So in this case, we're going to make the pawn actor the owner, and an easy way of getting this is by calling self, which will provide the object that you're currently working in. Then once we've created the actor, or spawned it rather, we can now call that set velocity value function that we had created earlier. So the direction that we wanted to move will get from the forward vector, and we're going to then multiply that by a speed that we want the bullet to move out at. So once we hook that up, we'll have had an actor that's been created in the world and its velocity set. First, of course, we'll need to actually hook that up to an actual event to our physical controllers. And we'll once again go into our project settings and our inputs. But now instead of axis mapping, we can set the action mappings, which are things like your button presses. So we're going to call this one fire right because it's my right hand. There I'm going to press the trigger, and I'm going to map it to the Oculus right hand controller trigger. So not the Oculus Go, but it's the one I'm currently working with, is the Oculus Touch right hand controller. Now that that event has been initialized or mapped, we can then add it to our event graph. Remember that you can only add events to the actual event graph. You can't add them directly to your functions. So there we have it, fire right, and basically on the press event, we will want to call our function fire right. So let's check that out. So here we are all running. We've got our hand controllers there, and I'm pressing the right trigger, and there we go. There are bullets are being created at where our hand is, and the forward vector is essentially where my fingers are pointing. And you can actually even see them interacting with collisions with the static environment. So now all that we need to do is do it for both hands. I'm imagining dual gun, one in each hand. So we will need to do something very similar to for fire left as well. In this case, I'm just going to create a helper function called fire, which will be used both in fire right and fire left, just so that I don't have to repeat my code. I'll use a helper function instead. So I'm just going to cut it from the fire right and put it into the fire function. And instead of directly mapping the right controller, I'm going to pass which controller, which will be left or right, as a parameter and hook that up instead. And then we will reuse that function in both fire right and the fire left functions. So here we go, we just get the right controller, pass it as a parameter into the fire function. And we do a similar thing on the fire left. We will call the fire function, but pass in the left controller as a parameter. And once again, we just need to hook the events itself back up to the left-hand trigger of the motion controller. We go back to our action mappings, add a new action called fire left, and then map that to the left-hand Oculus touch trigger. Here we go, we've hooked up the event, and let's give it a test. Both hands shooting from both the left and right hand. And there we have it. Thank you for watching today's video covering snap turning and bullet creation for our VR shooter prototype. The next video will cover the creation of an enemy that can track the player and can be shot. So, don't forget to like and subscribe to continue on our journey on building this prototype. See you then!